All right, good afternoon. Thanks for joining us today. Today I'm just doing a sort of an introduction to our wireless access points. We'll talk a little bit about some of the technologies in our access points, how we divvy up the different models of access points that we have in our portfolio, and we'll talk a little bit about the competition and how we stack up. As we go through today, use the question and answer interface in Zoom to ask any questions, and I will do my best to answer those as we go through. If I don't get to them while we're live, I will do it at the end of today's presentation, but I will answer those questions. So to start off with, we basically split up our current lineup of wireless access points into two different categories here. Those that fall under the flexible or flexibility here. These are access points where the model number starts with a 1 or a 2, such as an NWA 210AX, a NWA 1123 AC Pro, etc., like that. So these access points can be managed directly via a web GUI. Go to their IP address, log in, and manage them, or these can also work with our free cloud management platform, Nebula. So you get the choice of using either or to manage your devices. Then we have the Ultimate series. These are access points that start with the number 5 or the number 6. So NWA, 5123 ACHD, WAX 650S, etc. So these products, in addition to being able to be managed directly and in the cloud, these can also be managed using a local wireless controller. So if you need a management platform for your APs, and for whatever reason you don't want to use the cloud, the Ultimate series here, the 5 and 6s, these are the models you want to look at. We do still have some dedicated wireless LAN controllers available, the NXC 2500 and the 5500. But most people are using these days our security appliances as a wireless LAN controller. So most of our Zywall security appliances have built-in wireless LAN management into them. So you can, by default, they'll manage a certain number of APs, and you can use licenses to expand how many APs that device can manage. So that's the flexibility you get there. Our Ultimate series, when it comes to Nebula, are bundled with 1 year of Nebula Pro. This is an optional add-on to the Nebula Cloud Management that unlocks a lot of features there that are aimed at reporting and diagnostics and things like that. These models also often have advanced antenna technology, smart antennas, dual optimized antennas, and these are also where our products that are designed for niche applications such as in hotels or outdoor access points will all fall under the 5 and 6 series. So that's it for now about these different series. Now we're going to start talking a little bit about the hardware in general and some of the technologies in general that you'll find in our products. So here's an exploded view of one of our access points. Now it doesn't matter if you are buying a $99 NWA 1123 or if you're buying a $650, $700 WAC series AP. All of our access points follow this design philosophy. Whoops. So some of the things here you will notice. Behind the PCBA, we've got a large metal shield. This is a heat spreader. It's designed to pull heat off of the PCBA and vent it out of the copious amount of vent holes we have on the back of our access points. So this is a solid state device. There's no moving compartments. So heat fatigue is one of the leading causes of failure over time with access points. And so because we do this, because we draw and keep the heat off of the PCBA and keep it out of the housing, it allows us to offer a lifetime warranty on all of our APs, where some of our competition, which doesn't have vent holes, doesn't have this type of stuff, maybe limits their warranty to just 1 year or 2 years. Another thing we do here is we do not have any electrolytic capacitors. So electrolytic capacitors are made with basically a saltwater solution inside of them. They can burn up, they can dry out, they can leak. So we only use solid state capacitors to help extend the life of the device. Another thing you will notice when you look inside here is you will see a lot more RF shielding on the PCBA than you would see on most of our competitors. So this is just a little bit of extra isolation between different components on the PCBA, and that helps us with signal to noise ratio to give us a little bit better signal to noise ratio than we would have otherwise. Then on top of the PCBA, we've got another metal plate. This metal plate acts to, again, help shield the entire PCBA from external noise and also creates isolation between the PCBA and the antennas. So most of our competition mounts the antennas directly to the PCBA. We do not. So again, that separation and that little bit better isolation gets us better signal to noise ratio and will get you a little bit better performance, particularly on those edge cases, those users who are right on the edge of usable coverage. So again, this applies to all of our access points across the board. So one of the technologies you will see us advertise is something called dual optimized antenna. With the exception of the 1123 AC Pro, you will find this on a lot of our 5 and 6 series. The 11 AC Pro is the only thing in the 1 series that has this technology. So basically, your traditional access point is designed to be mounted on a ceiling centrally over the area it's going to cover. So the antennas that are in there are optimized with that assumption. The problem you run into with this is oftentimes you can't mount your access point on the ceiling for whatever reasons. They're too tall, building codes, your customer doesn't want you putting holes in the acoustic tile, whatever it happens to be, and you end up having to mount your access points on the wall. Now, the problem is that when you mount them on the wall, is that the antennas aren't optimized for that. They're sending their signal primarily up into the ceiling or down into the floor. You're not getting a lot of horizontal coverage here. So our solution for that is this dual optimized antenna. So APs that have dual optimized antennas, as the name sounds dual, we've got two different sets of antennas in these access points for each radio. And you have the ability to switch between ceiling or wall configuration. So those APs that you mount on the ceiling, you leave them in ceiling mode. For those that you mount on the wall, you can switch them over to an optimized pattern for wall mounting to improve the coverage. Another technology we'll see us using is smart antenna technology. So we're going to take sort of a step back and not immediately talk about antennas, but we're going to talk a little bit about RF and how it works and one of the biggest challenges you run into and have since the early days of Wi-Fi. So right now we'll start by talking about the 2.4 gigahertz spectrum. As you know, there's two major spectrums that are used in Wi-Fi, 2.4, 5 gigahertz. And there is now with Wi-Fi 6 enhanced a second or a third set of frequency, the 6 gigahertz. So today we'll just talk about the 2.4 and the 5 since that's what's mostly out there. And that's what we have. So 2.4 in theory has 11 different channels in North America. In some other countries it may have 13 or 14, but here in the US we have 11 channels to choose from. The problem is these 11 channels cover approximately 60 megahertz of wireless spectrum, and each Wi-Fi channel uses around 20 megahertz of spectrum. So because of this, you only actually have 3 channels that can be used without overlapping. So if you have two access points in the same area, using overlapping channels, they will cause interference with each other. And then we made this worse with 11N and everything since then. One of the ways they've increased speed on the 2.4 radios over time here has been to increase the width of, or the amount of bandwidth that's being used. So instead of using 20 megahertz for each AP, these APs use 40 megahertz channels to cover a much wider area and be able to essentially double their speeds. But the problem is you've only got 60 available. So as soon as you add a second access point, you've got interference issues. 5 gigahertz is a little bit better. So 5 gigahertz radios here in the US, we've got, I think it's like 26 channels here that we can use, assuming 20 megahertz in size. But you will notice here in the middle, a big chunk of these channels here we've highlighted in orange and labeled them DFS channels. So what are DFS channels? So this 5 gigahertz spectrum, before it was opened up for Wi-Fi use, was used by other devices. The most prominent being radar, and whether that's weather radar, military radar, airport radar, but there are other things as well that use this. So the way they got around this, and a lot of these, Wi-Fi devices to use these same channels that are already being used by other technologies, is this DFS, dynamic frequency selection. Basically, before your AP can broadcast on this channel, it has to listen and verify the channel is not currently being used. Um, and then it can broadcast on it once it's determined that. And then if it detects a legacy device using that spectrum, it then has to turn off the AP temporarily and either wait for that channel to open up again or switch to another channel. So one of the challenges you run into with this is you get complaints from users because they may randomly be kicked off because the AP thinks it detects a legacy device. It could be something, it could be a radar, maybe there's an airport nearby, or it could just be industrial interference. A lot of industrial equipment will put off bursts of RF. And so if you put it off in the right spectrum, the AP may think that, hey, there's somebody else using this channel. It will disconnect the users and switch channels. And if it's switching from one DFS channel to another DFS channel, there's a bit of a wait while it verifies the new channel is not currently being used. So it causes some user complaints about connectivity and reliability issues. Another problem you run into is getting this DFS certification can add up to 6 months through the certification process. So in the rush to get product to market and be the first to market with newer chipsets, newer features, what you often see is that consumer devices don't bother getting certified to use these DFS channels. So if you're in an office building or something like that and people are bringing their own devices from home, you will find that maybe, Bob's tablet won't connect to the network. Maybe Mary's new laptop won't connect to the network because it's got a chip in there that doesn't have DFS support. So this is something that causes a lot of calls. So because of these two issues, a lot of people end up deciding not to use these DFS channels. So that dramatically drops the number of channels available from 20 something down to 8 or 9 channels that you can use without overlap. And again, that's assuming 20 megahertz bandwidth. Just like with 2.4, some of the ways that 11N, 11AC, et cetera, have increased the speeds that they claim on the device is by increasing the amount of bandwidth that each device is using. So if you go up to 40 megahertz channels, you've only got 4 non-overlapping, non-DFS channels to use. If you're using 80 megahertz channels, you've got 2 that you can use that aren't in the DFS space. And if you're going up to 160 megahertz channels, you have to use DFS spectrum. So again, because of that, as you add more and more device APs and other devices that are using this spectrum that aren't necessarily Wi-Fi, Bluetooth, things like that, you end up getting interference. And when you have multiple devices using the same channel at the same time, packets get dropped, connections get dropped. It creates a bad environment for them. So that's what we call co-channel interference. Unwanted transmissions or signal noise that are using the same channel that you're trying to use to send data. So in this example here, we've got our access point up here on the ceiling. And we're adding a second access point that's on an overlapping channel. As you can see here, there is some interference. So one of the ways historically you've dealt with this is by turning the power of the APs down so the APs don't overlap over each other. That works. It definitely does help. But the challenge you run into is you're trading interference for a lower signal to noise ratio, lower coverage because you've reduced the power and the reach is less than it would be otherwise. So smart antenna is designed to help solve these issues with co-channel interference. It's designed to increase the number of APs you can have in one area, the number of users you can have in one area without them causing issues with each other, larger coverage areas, and the ability to reduce power consumption. So our smart antenna technologies, if an AP has smart antenna, it is on both the 2.4 and the 5 gigahertz radio. So this is showing here in this case, you've got your regular access point here, and you've got a source of RF noise, in this case, a microwave. When the microwave gets turned on, it puts out 2.4 gigahertz frequencies. which can cause interference and cause connected users to drop or performance to drop. So with smart antenna technology, instead of having this one fixed antenna pattern, we have the ability in real time and on a per user basis to go through hundreds and hundreds of antenna patterns to optimize the antenna pattern for the current RF environment. So that in our case looks at both optimizing the antenna coverage to boost the signal in the direction of the device it's communicating with, but also to tailor that antenna pattern for coverage to sort of ignore and not listen to these other sources of RF interference. So we've got a use case here. We took one of our APs with smart antenna and compared it to an Aruba, which does not have smart antenna. Otherwise, they are both very similar specs. And as you can see, significant difference in performance between the two different APs when it comes to coverage. The Zyxel product here is here in green. Aruba is in blue. So on top of our own testing, it's been a few years now, but a group at the networking group at the University of Brescia, and I'm probably pronouncing that wrong, in Italy, they got together because they saw claims that Zyxel was making, claims that Ruckus was making about smart antenna technology. They went out, bought some of our products, bought some Ruckus products, bought some Cisco products, which don't have smart antenna, bought some Aruba products, which don't have smart antenna, and they tested them. And they found in the lab, smart antenna gave, in a nice clean room environment, smart antenna gave you a small boost in coverage area compared to non-smart antenna products. But then what they did is they went out there and they retested it in a more real world scenario where there are sources of RF interference, where there are other devices being used. And they found that smart antenna makes a dramatic difference in real world utilization or real world user experience out in the field. So there's a link there on the page. That's a link to the original research paper where they go through all of their methods, all the different tests they did. So you can check that out. Also, if you just Google Zyxel white paper smart antenna, it'll take you to a white paper we've put together where we summarize the key benefits and the key results that came out of this university testing that was done. So here's just a quick summary of the results that they came up with. When it came to co-channel interference, we had up to 70% better performance. Specifically against Cisco, we were 56% better performance and even 45% better performance than Ruckus at that time. Okay, so that's it for antennas. Now we'll talk briefly about Wi-Fi 6. This is still a relatively new technology and people are still sort of getting a handle on it. I'm going to start here just by talking about in general terms what Wi-Fi 6 can offer. So in theory, Wi-Fi 6 can produce data rates of almost 10 gigabits per second. Obviously, this requires certain hardware that's designed to be able to support this. And just like any other Wi-Fi speed claim, a lot of that 10 gig is an overhead. So realistically, you would expect to see, real world throughput if you were doing like a speedtest.net or an FTP transfer of probably somewhere closer to 5 or 6 gigabits. Matt had a quick question. He was asking if we have any studies comparing us against Ubiquitis. Third-party studies, no. If you go on YouTube, and I think I've got a link to one of them in one of these upcoming slides, there was a reviewer who just recently tested both our Wi-Fi 6, or I think it was our 110AX, and I think one of our 11AC products against the equivalent Ubiquiti products. So he's done that up on YouTube. And then if you reach out to your salesperson, Jacob, David, Andy, we do have some stuff that we can provide. If you let us know which models you're wanting to compare, I think we do have some stuff we've done internally that we can share with you. Okay, anyway, back to Wi-Fi 6. So it's designed to increase capacity. Similar to smart antenna, it's been designed to boost how many users can be on one AP and how many APs can be in one area without causing interference with each other. A big one here is that, the big one here is this one here, it's dual band. So 11AC, well, most 11AC products have dual radios. Only the 5 gigahertz radio has the benefits of 11AC. The 2.4 radio is operating using 11N or Wi-Fi 4 technology. So with Wi-Fi 6, this is the first technology in 10 plus years that's boosted the performance and enhanced the abilities of the 2.4 radio. So it's really, really key here for those 2.4 devices, especially like in homes where like a lot of your, your smart home, those smart plugs, things like that. Almost all of those exclusively only use 2.4. So it's a big boost for those because, in my house here, I've got a ridiculous number of smart devices, and I have run into issues in the past with capacity when testing some products. So Wi-Fi 6 helps solve some of those issues. And another key thing to keep an eye out on is not every vendor who is selling a Wi-Fi 6 product has actually bothered to put Wi-Fi 6 on the 2.4 radio. So we just had that question about Ubiquiti. Ubiquiti's Wi-Fi 6 products only have Wi-Fi 6 on the 5 gigahertz radio. The 2.4 radio is still using that 10-year-old 11N technology on their so-called Wi-Fi 6 AP. So that's something to keep in mind and keep an eye on when you're comparing out there, is to verify that it's truly Wi-Fi 6 on both radios, not just half. Some other stuff that they've added here, they've increased the number of devices that can be supported in multi-user MIMO. They also now are allowing multiple devices to transmit at the same time. Previously, multi-user MIMO only allowed the access point to send data to multiple clients, but now with Wi-Fi 6, multiple clients can send data back to the access point at the same time without causing interference issues. And I won't go into today how that works. We do a Wi-Fi 101 webinar every now and then, and I sort of talk about how that technology works. Another big change here is the switch to OFDMA. This allows much, much better, more optimized use of the available RF spectrum. Something called resource unit scheduling. We've increased the QAM, so how much data you can encode in the same amount of bandwidth. Something cool here, BSS coloring, the ability basically to tag your signal with who's supposed to be listening to it, which helps reduce interference when you have a lot of APs near each other. So for instance, here's OFDMA. So right now, or with Wi-Fi 5 and older technologies, you were using OFDM. It essentially broke up the bandwidth into 20 megahertz chunks, where with OFDMA, we can break up chunks into as little as two megahertz channels. So you've got a lot of flexibility to specifically tailor the RF to the exact use and capabilities of the connected devices and distribute it much, much better. So we have this BSS coloring, which allows us to use, as I was mentioning before, basically have some overlap and avoid some of the interference issues that would normally cause by allowing the devices to know if the data or the RF transmission is intended for them and allowing them to ignore a weak signal that isn't intended for them. So it's kind of a cool technology there. So we'll talk a little bit here. Wi-Fi 6 also gets us some significant performance enhancements, particularly when it comes to airtime utilization with multiple users. So as you see here, we've got one AP in this test environment. The orange line here, this bottom line, this is an AC. This is aggregated throughput. And up here is Wi-Fi 6 or 11AX. And that's in the yellow line here. And again, aggregated throughput. As we increase users here, how much throughput can we get on that wireless connection? And what you see is as you add more and more users to an 11AC radio, the aggregated throughput actually drops because it's not very efficient in determining whose turn it is to broadcast and how they broadcast. Whereas with Wi-Fi 6, dramatic improvement in airtime utilization, allowing the aggregated throughput to basically stay the same. And again, it's the same sort of situation here. When you're talking two or more APs, you run into those same issues. As you add users, aggregated throughput goes down, and therefore, as you add users, the amount of throughput each individual user gets goes down dramatically. Wi-Fi 6, significant performance increases here on these dense APs where you've got a lot of users on one AP. So I want to highlight this. This is a slide I've been talking about for a while. This has to do with when Wi-Fi 6 isn't Wi-Fi 6. Basically, anybody can call anything Wi-Fi 6. There is no standards body to enforce what's going on. And when the rush to get products out to market. Things were a little bit, I would say, marketing wise, we're a little bit more honest previously. So we saw the same thing happen with 11N, right? There were these early chips that were roughly based on the 11N spec that was still being modified and going through the IEEE approval process, but they supported some of those new features. So with 11N, those were marketed as pre-N. You would actually see that on the box of the product when you go to buy it. With Wi-Fi 6, they did the same thing. There were these early generation chips that came out that didn't support all of the features that make Wi-Fi 6, but they supported some of them. And those products, a lot of them were just marketed simply as Wi-Fi 6, even though they are missing these key features. So when it comes to Zyxel, all of our Wi-Fi 6 products have Wi-Fi 6 on both radios, and all of them support the full Wi-Fi 6 official standard and all of those T technologies that are in there. So I've got a comparison here between Qualcomm Gen 1 and Qualcomm Gen 2 chips. There's actually a couple different generations of the one here. Similar things go on with Broadcom, and you can see these early Gen 1 chips are missing some important features, such as upstream OFDMA, the ability to do BSS coloring, things like that. So David's asking if the WAX 510D supports Wi-Fi 6 on both frequencies. The answer is yes. All of our APs, all of our Wi-Fi 6 products are Wi-Fi 6 on both radios. So you'll see some products, we're missing out, these early products. And you go, well, that's just the older products. But the problem is some of those products are still out there. And Netgear just recently launched some Wi-Fi 6 products that are still using these old Gen 1 chips that are missing these features. In fact, they took an old branded it as a Netgear product. So that's something to be aware of, and it's not something you're necessarily going to see looking at the product. The product page will say Wi-Fi 6, and it'll highlight the handful of features they do support and just won't mention the stuff that's not supported. So it gets kind of tricky sometimes to know what's truly a Wi-Fi 6 product and what's not. Some of these features are really key to the performance benefits you get with Wi-Fi 6. So it's really important to have a true Wi-Fi 6 chip on there. Okay, now we'll start talking a little bit about the products. We'll go briefly through some of the products here. So this is talking about the on-premise controller. I don't have a slide breaking down what's in standalone, what's in Nebula. That's been around for a while. But for those of you that want to do management, but want to do it locally or instead of through the cloud, the on-premise controller is the way to go. Again, this is that Wi-Fi controller that's built into our security appliances as well as our standalone NXC models. And almost all of these features are also available in the Nebula cloud. So intelligent dynamic channel selection, so you don't have to go through and manually set channels for each AP. What we call zero AP config deployment. If you plug one of our APs in on your network and you have an active Zyxel wireless LAN controller, the AP will automatically find that controller and switch itself into controller managed mode. So you don't have to go into the AP and tell it, hey, you need to be in managed mode. It'll do it automatically itself. And as a tangent here, if you're doing Nebula, it's the same sort of thing. There's nothing you have to set in the AP. You simply assign it in Nebula and it will realize it should be Nebula managed and switch to Nebula mode. We support mesh, fast roaming, 11R KV for those of you doing voice over Wi-Fi. Rogue AP detection and isolation, although I will warn you about using isolation in the US. There have been people who have gotten in trouble for using similar tech because the FCC rules in the US say you cannot interfere with other Wi-Fi devices. So just be aware of that technically if you're doing Rogue AP isolation, you may be violating FCC rules here in the United States. Dynamic VLAN, the ability to assign VLANs as the user authenticates uniquely there using one SSID, AP load balancing, client isolation, band steering, so all the stuff you would expect to find in a managed AP solution. So here's a breakdown here of some of our most popular security appliances. This column here is telling you how many devices can be managed out of the box. So you see here, 4 to 8. In the case of our ATP series, we can get up to 520 APs. Over here, out of the box, depending on whether or not you've got a active gold subscription. That's why there's two different numbers here. And then this column here is showing you how many APs total can be unlocked for management. So you can see here a VPN 300 could manage up to 264 APs. So you can manage 8 out of the box, and then you can buy licenses to unlock up to 264. The VPN 1000 can manage up to 1,000 APs. The ATP 800 can manage 520 APs. And then we've got here our suggestions for the group size. When you're managing them, we want you to group them together for doing things like load balancing and stuff like that. So this is our suggestion on the maximum APs per group. So again, if this is something you want, you can reach out to your salesperson. They can provide you a copy of this slide with this information. Most of it's also on the data sheets for the individual security appliances. So you're asking before about, Ubiquiti Comparison. So this here Network Advisor on YouTube, just go to YouTube and, type in Network Advisor Zyxel. He's now done 2 tests comparing our product with Ubiquiti product. So, go check out his reviews, check out his experiences with the 2 different products. So now we'll start going through some of the individual models. Here on the 1 series, we've got the NWA 1123 ACV3. This just recently this year replaced our 1123 ACV2. Gave us a little bit of an upgrade going from 11AC to 11AC Wave 2. We've got our 1123 ACHD, faster Wave 2 AP. We've got our 1123 AC Pro. And these all match up nicely with Ubiquiti products, very similar pricing, but free cloud management, lifetime warranty, live phone support based here out of Southern California. So a lot of benefits, very similar prices, and should be better performance in almost all cases. Going up here to Wi-Fi 6, we've got the NWA 110AX and the NWA 210AX. Primary difference between these 2 models is the speed on the 5 gigahertz radio. The 110AX has a gig Ethernet connection. The 210AX has a 2.5 gig Ethernet connection to help support those faster wireless speeds. So going up to the Ultimate series here, we have our soon to release WAC 500. Those should be out very, very soon. So this will be our cheapest AP that you can buy that can be used with our new work from home functionality, which basically turns an access point into a VPN appliance that can be managed directly in the organization, just like you do any sort of local device, easily bridging remote workers into the home office without worrying about, port forwarding on the router and things like that. So this will be the cheapest model that supports that. We've got our WAC 6303DS. This is our cheapest smart antenna access point. For those of you doing hospitality or similar things, we've got these square APs. These both have smart antenna built in on them. Excuse me, no, the 5302 has smart antenna. The WAC 500 does not have smart antenna, my bad. But they all have pass-through ports. So you run Ethernet into them on the wall, and then Ethernet can come out so you can connect additional devices. We have PoE pass-through. So these are really popular for hospitality deployments where you'll put this in for wireless in the room, and then you can run Ethernet out to the TV set. You can run Ethernet out to and PoE for the phone, things like that. And then on the higher end of things, we have our WAC 510D, the WAC 610D. Main differences between those 2 models and the NWA 110 and 210 is these both come with dual optimized antennas and 1 year of Nebula Pro Pack bundled with them. And then we've got our flagship device there, the WAC 650S. It's our fastest AP. It's got a 3rd dedicated radio for RF scanning those 5 gigahertz channels. It's got a 5 gig Ethernet connection, and it's got BLE Bluetooth built in. And then for outdoor stuff, we've still got our 2 old standbys here, the WAC 6553D-E. This one does not come with antennas. You can buy our ANT 2105s to add to it, or you can source your own antennas for your own custom application. It supports standard N-type connectors, so there's lots and lots of different antennas out there that are compatible with it. We have our WAC 6552D-S, which is our smart antenna outdoor AP. One key thing to know on this guy here is it is a directional beam. Even though it's smart antenna, it's specifically optimized to cover an area of approximately 90 degrees horizontally. The idea being here for use in things like sports stadiums and things like that, where you're wanting to focus the beam and the coverage on a certain specific area. If you're doing 360-degree coverage, these have been designed so you can mount 4 of these on the same pole, and they will not interfere with each other and will provide you the 360-degree coverage. And then we've also got our outdoor enclosure here. This outdoor enclosure fits a lot of our indoor APs and allows you to make them affordably into an outdoor AP for outdoor coverage. Check the price sheet you can get from your salesperson, and it lists the models that are compatible with it. It's a lot of them, including some of our new Wi-Fi 6 products. It's a great affordable way to do outdoor. If these two guys here in the super heavy duty outdoor, enclosures, the built-in heater and stuff like that, is a little too expensive for what you're trying to do. So we'll take a look here and just highlight a couple of our competitors and a couple of our different models real quick. So in this case, we'll start with our 1123 AC Pro. Probably the biggest competitor to it is the Ubiquiti UAP AC Pro. Prices on these should be pretty comparable between the two. We give you more output power, 27 dBm versus 22 on the Ubiquiti. More SSIDs, double the SSIDs essentially. We've got dual optimized antennas built in versus the traditional standard static antenna. SNMP V2 and V3 support. We have dual image. So basically a dual image means if you're doing a firmware update and something happens during that firmware update, it will not brick the AP. The AP uploads the new firmware into a separate piece of memory, verifies it works, and then switches over to it. If for any reason that firmware update fails, it goes back to the previous firmware that was on the device. And then probably the biggest thing here is just warranty, lifetime warranty versus a 1-year warranty. Going up to Wi-Fi 6, we put in here the WAC 510D. So this is competing with the Aruba AP505, the Ingenious EWS 357 and ECW 220, and now the Netgear, and I forget the Netgear model that's using the same hardware. Big difference here is it's not true Wi-Fi 6. It is a pre-Wi-Fi 6 chip missing some key features. We have dual optimized antenna, Aruba and Ingenious do not. We've got higher output power from the radio. This is wrong about the monitor radio. I apologize. I need to fix that. That should not be on there. Ignore that. Ignore the Bluetooth here. Can't believe I missed that before. So I'll fix those two things on the chart, but everything else is right on there. And then the 650S. So here we go. Oh, wait a minute. I'm wrong. It's accurate. It's got the X instead of check. I got confused there. I confused myself. I apologize. I'm sure I confused a few of you. So this is right. I just didn't think this should be on there at all. And then the 650S, so this competes with a whole bunch of products, Meraki, Cisco, Ruckus. And you can see sort of the same story with the other comparisons. Only us and Ruckus have smart antenna technology. Cisco and Aruba don't. We've got higher output power than most of the others. We tie with Ruckus here on the 5 gigahertz radio. We have this dedicated monitoring radio, something only Meraki has. We've got Bluetooth built in, something everybody does in this class. We've got 5 gig internet connection where most of our competitors are 2.5 gig Ethernet connections, which means that data going from wireless to the LAN has the potential of being bottlenecked by that wired connection. And then, of course, we've got free cloud management, where most of these other guys, you have to pay for cloud management, stuff like that. So that is it for today's webinar. If you have questions, go ahead and start sending them in with the question and answer. I've been asked here to let you guys know, all of our webinars are archived and published to our YouTube page. Also, occasionally some other stuff gets published to our YouTube page. So it's right there. It's Zyxel America channel. So that will be only stuff that applies to those of us here in North America and won't cover any of the service provider products. And then we're also on LinkedIn if you'd like to meet us over there. My email's up here on the screen, seanr@zyxel.com. Feel free to reach out to me offline. Let me know how today's presentation went, what you think I could do to make this presentation better, ideas for other sorts of webinars you would like to see me put on talking about wireless, consumer products, things like that. Let me know. I definitely need your support, your ideas as to, what sort of webinars you guys would find valuable or you think your employees would find valuable. And then also just draw your attention. We do have a user forum, forum.zyxel.com. That is where you will find the latest updates, security announcements, things like that. It'll let you interact with your other Zyxel installers and users. And it's also a way where you can reach out and actually know that suggestions and feedback are getting seen by our product management and our R&D teams back at our headquarters. They do monitor those forums, and occasionally we'll even drop in and answer questions or provide solutions for things that people bring up, although that's not their main thing. So David, I don't have an archive of this, so just reach out to your salesperson, whoever it is, Jacob, David Chen, and they can provide you that link once it gets uploaded to our YouTube, or you can simply just go to that YouTube, our YouTube channel and find it there. It should get posted up probably by tomorrow afternoon, Monday at the latest. And I've also done this presentation before, so there are past versions of today's webinar that are available for you to stream right now if you want to on YouTube. So it doesn't look like I've got any other questions. So thank you everybody for joining in today. I'll go ahead and end today's webinar. Hope to see you at a future webinar. Thank you.